Hello everyone. Uh, we'll start the lesson soon. Let me share the slides first. And let me post the initial code examples. And let's go here. Okay. Linked lesson. Good. I think we can start. So the purpose of this lesson is to talk about attributes, and we'll talk about basically two parts of attributes: how to use them, how to use common .NET attributes to make your development life more easier, and how to make your own attributes in case you want to innovate and do something nice by yourself with your own custom attributes. So we'll talk about the following attributes: about debugger, display, obsolete, data annotations, flags, and then we'll talk about how to implement your own attributes, how they work under the hood, a little bit about reflection, and how to consume the attribute. We'll try to reverse engineer data annotations attribute, data annotations validator, and see how it works under the hood. So let's get to it. So attribute essentially is like a flag. By itself, it doesn't do anything, and it will only do something in certain context. So if I put an attribute required to a name, that's data annotation. And if you, let's say, try to save something that is required to a database and you don't have it filled, then it will complain. If you submit a form with a field that is required, it will complain. But if you work with it in memory, nothing will happen. So it's all about the context. Only when you trigger the context, which supports working with the attribute, it will do something. So only when you trigger the context, when it passes the context. Another example would be if I have a required field and it passes from an HTTP request to some controller method, it will throw an exception. It will give a bad request, field name was not provided. So attributes don't do anything by themselves. They need context. They're flags. They are usually just silly, empty, logic-less data. There are examples where it makes sense for an attribute to carry logic, but it's slightly more rare. So let's continue. About attributes, as I said, they don't do anything by themselves. And by convention, actually, you can simply remove the word attribute from the full class of attribute. Like the full class name for required attribute is required attribute. But since calling every attribute is quite redundant, so you can amend. You can forget or ignore the attribute in the name, and that'll be enough. So required is enough. Required attribute works as well, but it's redundant. So as you can see in the warning, it suggests for you to remove it. Next, so attributes will always be consumed from the outside. They won't do anything by themselves. And if you do need to work with attributes to consume them, you'll need to apply some sort of reflection. And about that, we'll talk on the second half of this lesson. So in the link below, there is a list of all attributes in the .NET framework, and there are hundreds of them. Hundreds of them, but only a few actually need it. Hello, Sian. Hello, Mikhail Fox. And hello, Dave. Hello, Royalov. Let's continue. Is it still frozen? Is the stream frozen? Okay, let's continue. So debugger display is an attribute that can be used to display some extra info when you hover over objects during debugging mode. So for example, if I have a dummy with display class, and above it I put an attribute called debugger display, you will see this kind of message. Relevant state x1 is x1. So if we look at the result while debugging, you see I'm debugging this object, and what I actually see in the object is not your default string implementation, but rather my custom message that I put for the attribute. So debugger display is a way to show custom message when hovering over objects during debug mode. So it's very useful for diagnosing your application, for debugging. Um, so in order to use this, all you have to do is to do a using diagnostics assembly. So that's the attribute. It comes from system diagnostics. Obsolete is another extremely useful attribute, especially used in production. When, for example, you have several versions of your API and you start deprecating the old version as it's already replaced fully by the new one. But since all clients still depend on the old API version, you cannot just remove it. Or maybe you can remove it, but you simply don't have time. So a quick solution, or like a smart way of adding a to-do to yourself via warning, would be marking such API with an obsolete attribute. And marking it with obsolete means that it will give a warning if you use a class that's marked with such an attribute, a class or a method. So here you can see I have my own attribute, and this attribute itself is obsolete. This doesn't work only on attributes. It can be on a method, it can be on a property. It works on everything. So if you decorate something with an attribute such as obsolete, it will give a warning as the above. So if we look at the warnings, you see required attribute is obsolete. Use data annotations require attribute instead. So I used this required attribute in 3 places, and therefore I get 3 warnings. And each warning has this message that I wanted to have. We already talked about data annotations. So in C# we can do validation of our data through data annotations. And there are a ton of different data annotations, validation attributes like required, min length, max length, regular expression, credit card, email address, and so on. You don't have to write your own regex, or you don't have to write your own custom validation because it's already done for you. And to use these attributes, all you have to do is to refer to system component data annotations assembly, and here you have it. Again, a reminder, by itself, if you create a name, like if you create a person with invalid name, birthday, email, or weight, nothing will happen. It will not get triggered until it enters a context where the validation happens. And the context is, again, passing a boundary to, let's say, a controller, it will be validated then, or saving into a database using entity framework, it will be validated then, or submitting this to some web form, it will be validated as well. So a reminder, by itself, they don't do anything. And it depends on the context if it gets triggered or not. And the thing that actually calls all of them, validates all of them under the hood is data annotations validator. We'll talk about it in live coding part, how to do it in more detail. Another useful attribute is flags. Flags is an attribute which is used to combo different enums using bits. And here's how it looks like. So basically, if you look at this picture, you can see if something is off, it's 0. If something is on, it's 1, right? And you can combo like this permissions. So simultaneously, I can have permissions to read emails, to write emails, to read logs or write logs. And it's essentially either 0 or 1 for that one bit. So I have 4 permissions. Therefore, if I have no permissions, there will be 4 zeros. But if my permission is read email only, I'll have 1 at the first 0 position. If my permission is write email, I'll have 1 at second 0 permission. And the same for logs and write logs. So if I have full permissions, I'll have 1, 1, 1, 1 in my binary number. And if I have no permissions, I'll have 0, 0, 0, 0. And how does this work? Let's see. You see, using this symbol, I can combine permissions. So here I say that I have both permissions for read and write email. And if I actually print what I have here, even though it's not an array, it's just some enum that's tagged as flags, it will print those permissions, separating them with a comma. All permissions that I have there. So I have permissions for read email, write email, and it will print me exactly that. Even separated with a comma, which is also great. And then the enum that's marked with flag has a method called hasFlag. So if I pass if I call hasFlag from this enum, read email, I will be able to check if this specific permission exists in my permissions, So it's very useful. It's definitely used in practice, and I've used it a few times myself personally. It makes it will result in if switches or similar, but it still makes managing permissions or similar quite nicely. Like, it's a nice addition, I think. Elegant addition. Literally like a switch-based system. And now that we know some of the .NET attributes, it's time to try and make our own. So to start with making an attribute, we first need to define what it targets. And as we already saw, it can either target a class, a method, a property, and many more things, in fact. And here is a total list, actually not a complete list, there are a few targets missing, but roughly a list of what an attribute can target. And from this, you can see that it can target pretty much anything that is a type or a member. You cannot target only the code that is inside a body of a method, pretty much. The rest you can target. A lot of targets, and by default, you can target everything. So if you don't have this attribute above your attribute, you can target everything. Like, you can put your attribute above everything. And how does it look like? Here I defined my own custom attribute. Um, all I had to do is to derive from the attribute class. That's it. Specify what it targets and derive from attribute class. This means I um, that I target everything, that it will work on everything. So to be more specific, this should have been to target either uh, classes, to target only properties or fields. That would have been a better way. All right. So in our attribute, we can have some state, we can have some behavior as well. But normally attributes provide those positional default argument values. Whatever must be set, you set in the constructor. Whatever can go optional, you set it as an optional parameter. You do not expose, like, you do not expect the error message to be set outside the constructor. Everything that can be set in an attribute should be set in a constructor of that attribute, because that's the only place you'll be dealing with the attribute in terms of initialization. All right. So required attribute done in our own way. You might wonder, why did I make it sealed? It's normally recommended to have attributes sealed. I cannot explain why, I don't really remember why, but for custom attributes they say seal it. I would presume that it could potentially introduce extra complexity, as you already derive from one class, so you would derive from another class if it wasn't sealed. That sealed modifier is a kind of prevention for that happening, because we want our code to be maintainable. And how do we use our custom attribute? Just like any other attribute, you just put it above what it supports, what it can target. So it can target properties, pretty much anything in our case specifically. So we put this attribute above properties, and well, will it do anything? Not really. It won't do anything right now. There is one step still missing. And that step is actually using the attributes. And the process of using attributes is actually involved in reflecting the type that the attribute is added and checking everything that the attribute could be applied to, and then checking again the state of the thing it was applied to. And then depending on the results, on the state, on the attribute, on its own state as well, only then you apply some behavior from the outside. If you look at the picture on the right, you can see a reflection. And I think it's a good picture to illustrate what reflection really is. Basically, reflection is made of two things: of static metadata about some type and its state. Using reflection, you can get all the information about a type. Uh, you can get all the information about a type, like a class name, all the properties, all the methods. You can even get private fields or private methods. So if you really want to call private methods, there is a workaround. Use reflection, though I don't recommend that. Using reflection, you can also get data of an object. So all that you can do with normal code, you can do with reflection, except that it's way slower and shouldn't be abused. However, reflection is the only way when it comes to consuming attributes. There is no other way in C# to consume attributes. And here you can see basically what .NET does, probably way smarter than I do. It's just a poor man's version of data annotations validator. So here, if we break down this method, there are essentially three steps. We first get the type of an object that we passed for validation, and we get all the properties. After we got all the properties, we start trying to get all those attributes that a property has, more specifically the attribute that we care about, required attribute. So we try to get a required attribute here. And finally, if required attribute is actually on top of our property, we continue applying validation logic. What's our validation logic? Well, we want required means that it must exist. So we get the value of this property in this object. And then we say that if the value is null, well, we need to validate it if the value is null. And if the value is null, we need to give some sort of an error message. And our attribute, um, by default, has null error message, empty string error message. And so if we didn't provide any error message, it will say by default that this field was required. That's all it will say. That the field that was not provided and did not have a value, yet it was tagged as required, it will say this property name field is required. And if not, if we do have our message, it will say that it'll print our own message that we gave it with the validation, with the required attribute. So 3 steps: get the type, get the properties, get the attributes, and get the property values. Yes, of course, it could be done in many ways. Actually, the .NET framework does it in many ways. There is try validate, there is validate. I wanted to do it like this, just give a slightly easier demo. Of course, you could throw an exception. But again, it depends on your use case. And that's all that I wanted to show about attributes and both custom and built-in. For Aurora who didn't see, for example, attribute is not required to be written, only class name without attribute. And yeah, now I would really appreciate if you would write one thing that you think you understood well in detail in a few sentences, and one thing that you would like to understand better. And I'll be right back because my throat is very sore. Okay, I am back. Let's see. Uh, um, Roll offset. I think I understand attributes and flags well. Reflection has to click, I think. I do not see how I could use it in a project. Under set, as far as I can see, according to Microsoft Docs, ceiling attribute eliminates the search in the inheritance hierarchy. Oh, okay. That's a really good point. Thanks for reminding. And I wonder if sealed is ever explained in the course. It was already explained, I think. I didn't catch up well, so I think I'll need to rewatch. It was chapter 2. You did not miss a lot. Yeah. Okay. Mihail said, need to rewatch the recording. I actually know some stuff about reflection from what I read today. And like I said, it's useful to get all public properties from an object. It is, however, that's a rare case. Let's move on to live coding part. So I wanted to demonstrate a few things. Yeah, for CSV header, it's useful. I agree. For those serializations thingies, it's useful. Yeah, attributes are quite common in Unity. All right, so we have our things, and actually we will start from a demo how you can call code that is not .NET framework, that is not inside CLR, common language runtime. How to call, for example, code that was written in VB6 or older. How to call code that was written in C or C++. Well, you can do that with attributes, and you can do it from C#. The first demonstration, let's turn all those things off. And the first demo is interrupt with unmanaged code. You definitely don't need to remember this. It's just some geeky stuff that you can do. Just to be aware that you can do stuff like that. This code is literally taken from MSDN docs, slightly simplified and slightly modified. But the point remains. User32DLL, if I'm not wrong, was written in C or C++, not in C#. It's something that Windows have natively. And basically, we import this DLL. And by importing this DLL, we now, if we write this, we now expose the method that this DLL has. So if I call this method like this, see what happens. I just called a message box from a console application, which normally doesn't even happen. You can only call message boxes from its native environment, such as WinForms or WPF, but you cannot do this in console application normally. However, I just did by importing this DLL. So what this basically says, it says that I import this method from this DLL with this signature, and therefore I can call it like this. I think name is irrelevant. It's just a delegate that fits this structure. All right, so that's the first demo. Now, data annotations demo. Yeah, I think it's in C++. I think it would be madness to write Windows in C, and C++ is still reasonably high level and fast. The next demo is the person. And I think out of all those attributes, the only attribute that is quite interesting is this regex attribute. So I can apply a regular expression, which is basically a pattern of symbols that I allow on the name. What do I allow on the name? I allow the name to have only alphabetical symbols. I also allow it to have, you know, I think in some countries there is like some name muck name or el bueno or something like that. You know, those short additions to the name, Mac, L, or so on. Apostrophe. Well, this is apostrophe, but the thing that is in the name, like like Mac or L, I don't know, and so on. It happens in the name. Yeah, it happens in the names. Therefore, it also needs to be allowed. And white space then the name is allowed because it's full name. So it can be 2 words or 3 words sometimes, you know, if you have three names. So all this is allowed, and I say that at least a single character needs to be in a name, but it cannot be longer than 40 symbols. Probably 40 symbols is too little. I can imagine name being longer than that, but that's beyond the point. How do we validate this, or how does it work? First, let me slightly fix the namespaces. How does it work? We have a bunch of people that we created. So this person has correct name, but as you can see, birthday is required and it doesn't have one. This person has a good name and a birthday and an email, so this person is fine. This person does have a good name, does have a good birthday, but its email is missing an at symbol. This person has a bad name because it has numbers in his name. And this person has a bad name for multiple reasons. One of those is that 40 symbols is maximum allowed, but it has 1, 2, 3, 4, 5, 60 symbols. And here we have that we validate those 5 names. If I run this code up to the breakpoint, you will see that nothing happened. Like no messages, no exceptions. So it's a proof that data validation of data annotations happens only if it enters a certain context. And what context does it enter? Under the hood, it's all done by validator. And here is how it works. I made a static method and my own validator, which basically hides the complexity around the validator that comes from component model data annotations. And what does this do? We basically load or create a list of results, a list of our validations. We create a validation context with an object that we want to validate. And then we validate this object with all the stuff that we have. And in the end, the results, in other words, errors, are populated after it's validated. And if it failed to validate, well, the results will have some error messages. And here we basically for each those error messages. Something like this will happen in contexts like I mentioned at the start, like in the web, when you, let's say, send HTTP request and something is missing, something is invalid, or when you try to save data using entity framework, that will also fail. or when you try to submit a form, either in Windows Forms application, WPF, or the same web, it will give some sort of an error because this validator will be invoked. Let's see it in practice. If I run the code, if we go back to the context, let's see the error messages we got. For the first person, it says birthday field is required. Email is not mandatory, so it didn't pick on. But birthday is required, and therefore it gave an error. For second person, it said, well, that's not a valid. For this person, it was all good. But for this person, it said, well, email is not correct. That's it. For the fourth person, it said that it doesn't match the regular expression that we wanted in the name because of the digits, and that the birthday is not provided, so it's invalid. And for the last person, birthday is not provided and the name is too long. Therefore, regular expression, this part specifically, is not fulfilled. So here we validated 5 people. Quite simple, quite self-documenting and obvious. Let's move on. The example where we display, the example where we display some different error message, some different metadata for debugging. It's quite useful. Here we have 3 classes. A dummy class, which has no toString method, but 7 properties. So 7 properties, 7 strings, not very meaningful, but to prove a point. What point, you'll see. And then we have another class. I don't need those, and it was supposed to come from this one. Oops. So first class, 7 properties. Second class, 7 properties with method to convert this object to string. And last class, with this to string method, but also with debugger display to display the first x1 property. So if I run this code, and if I inspect the state, it's quite interesting. The first type did not have the string, therefore we only see the type here. We can inspect the state if we want, but it's not printed in one single line. And for example, the state I care about the most is the first property. The rest I don't care. If I look at the second dummy, you see it basically prints whatever the string was. That's the default behavior for displaying the description of an object when you hover over it. It will display whatever the string was for that object. So it displays the full concatenated string of all 7 properties. And finally, if I look at the third dummy, it displays exactly what I wanted because I had this attribute. So all the noise removed, and it's a nice first display of this property. All I wanted is to know the value of x1. And as I can see, the value of x1 is third dummy. Neat, isn't it? let's move on. And about permissions, as I mentioned, we have a permissions enum where each bit represents each permission. So read email, read logs, write logs. Already demonstrated this in the lesson. By toggling those bits to 0 or 1, I can change permissions. Here I say my permissions are read or write. And if I print, it will print read and write. And I can check also that permissions has a flag or not. So you can see the results that it indeed did what I asked it to. Let's move on. Now it's a demo on our custom attributes. And I was trying to figure out all the potential cases, how could you implement attributes, and actually for all cases involve reflection one way or the other. However, some cases allow you to call attribute internally, not necessarily externally. And how is it done? Imagine you have a game framework like Unity. In Unity, you have attributes like required component attribute, I think it exists, serializable, and many others. How does it work? And the interesting bit, how does it work, comes with inheritance for that specific case. So here I have important item class. In Unity, it would be game object, let's say. And in the constructor of this class, I can check, hey, give me print attribute of myself, of my own class. Give me all print attributes of my own class. Not all, just one, because it will ever be one. So if I get all my print attributes, well, if I get my single print attribute, I can then do something with it. And in my specific case, I want that if something was decorated with print attribute, upon initialization, I want a message to be printed, right? What message will be printed? And here are the examples of using it. So briefing case had no attribute and nothing will be printed. However, evidence has this message, this attribute and this message. So when I create evidence, it will be printed, somebody accessed the evidence. Let's try it out. In the example, you can see somebody accessed evidence and demo. And you can see I didn't print the message myself. It was done by the attributes. So I created 3 items and one of them was evidence. So somebody accessed evidence. Let's move on. Last demo is for custom validator, which we already covered. So I have my own required attribute. And actually this required attribute should target attribute target or usage. Right. And attribute targets, I want it to target only fields or properties. So my attribute can target fields or properties, and it makes no sense to allow multiple required arguments to be applied. That's the default, but let's leave it as this. Also, my attribute exposes error string, and I can either supply it or leave it as it is. If we go back to how it's getting validated, we can see those steps that I mentioned. We basically support validating any object regardless of the type. And we get a specific type by using the getType method. From the type, we get all properties because that's what for we apply the attribute. For a more proper solution, I should also get fields, but that's not very important. So I get all the properties. And then out of all those properties, I try to get the attributes. How does the getting of an attribute work? This is actually my own class as well. Basically, property has a method getCustomAttribute. If you pass a type of an attribute, you can get an attribute. The problem is that it's object. If you see what's returned, oh, it's not an object. It's returned as an attribute. Hello, Timmy. It's returned as an attribute, but I want to treat it as a specific type, as a specific attribute, the one that I required. So I made an extension method which does that for me. So here you have it. You pass an item. You ask it to get an attribute of some type. You get that attribute. That's the implementation. And for this one, you pass a type. You get that type. You based on the generic, you get the attribute that you wanted, and you return it as exactly the attribute that you wanted. So here we have required attribute. We say that if it's null, so if there was no attribute, we don't care, and we skip. And if there was, we validate the value to not be null because it was required. And we either print a default error message or a custom one based on if it was defined or not. If I run the demo, which looks like this, you can see the first person didn't have birthday, the second person didn't have a name, the third person didn't have a name, and the third person, this one, the last two messages for the third person. And the third person, me, I had everything, so no error. Shh, don't expose me. All right. Yes. Yeah, so that's all the demos I wanted to show. I'll leave the link to the code already. Right. And today we'll actually have Kahoot as well. Let me link. Kahoot. Teach. Yes, weird. For this Kahoot, oh, it's gonna be loud. Okay. For this Kahoot, we will be covering both the previous topics of LINQ and the current topic of attributes. So it will be a mix of the last two lessons plus this lesson. Let's wait some more time. I'll give it half a minute more and we'll start. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Question number 1. Is it true that all of LinQ methods are static? And the answer is yes, because they are extension based and extensions have to be static. Which data type is targeted for most of the LinQ methods? Yes, it's not list because it needs to be more generalized. If it was iList, it would be too specific and not support most types. Hello, select AA. What will this produce? Well, it will not produce an enumerable t because it's invalid in the first place. When you get the result, you get a specific type always, and the result will be char, enumerable char, because that's the t. What it will be? It will be char. Well done, Aurora. Which of the following is used to get a maximum even number? Yes, the first one, uh, not the last one, because you mixed. This is for not even number. So if it divides from 2, it's even. If it doesn't divide from 2, it's not even. All right. Int a equals 5. Var o equals new with a. Console write o. What's going to be printed? O a equals 5. O equals 5. And the answer is a equals 5. That's right. For those who wonder how that works, new a is an anonymous object. And when you print an anonymous object, by default, it will print in the format with those brackets. And for every property, it will print its value in this format. Property name equals a value. And when you create an anonymous object, it takes a property name based on a variable name if you didn't say otherwise. Which of the following is not needed in order to implement an extension method? Is not needed. Ten seconds remaining. And the answer is public access modifier. Because you can have private extension methods as well. Private extension methods must be in a static class. That's one of the requirements for them. They cannot exist in a non-static class. They must be a static method as well. Well, because every static class must have only static members. And this keyword, as it's a way of marking it as a special method which can be called from the thing that you make an extension for. Private extension methods work the same way. I also don't see any use cases for them, but they are valid. Let me make a demo. For example, public static class X foo, let's say, private static void bar this string text. Let's say you do something, and in this class, let's say, exposes something that you want to work with a string. So x a foo bar, I guess. And what if we want to, so we pass a string, maybe string, yeah, text. So what if we want to do something like this multiple times for whatever reason? Because it's right string. Let's make a really stupid method then. It just returns what we passed. Oops. So we say foo bar testing. If we run, you can see it prints testing. So that's perfectly valid. I agree that it's certainly, I haven't needed such a case myself ever, but it's not impossible. Like logically it could happen. But out of all those, if you, let's say, have a non-static class, you won't be able to have this because you see, it must be a non-generic, non-nested static class. So it has to have this, it has to be static, and the class itself has to be static. Therefore, yeah. Next. Um, the class itself has to be non-generic, not the method. Because how can you have a generic static class? It doesn't make sense. Yeah. I don't even know why they put it, to be honest. Non-nested, non-generic. Non-generic is impossible. A generic static class is impossible, I think. So that one can be removed. We can try actually. For science, okay? Public static class bar T. Okay. How does that work? I don't know. I cannot answer. I really cannot answer. I don't know. I'm guessing as much as you. I don't know. If it's a good thing to investigate. Next, you have a list of people, and each person has one to many phone numbers. What to do to get all phone numbers without people, just phone numbers? So you have a list of people, and every person has a list of phone numbers. What do you do to only get phone numbers, like a total list of phone numbers? Which one of those would be the most suitable? And the answer is select many, because that's the most appropriate one. Because the problem here essentially is flattening many nested lists and making one single list out of them. Royal off on fire, catching up. You have a list of people and a list of phone numbers. Again, what do you do to group people with their phone numbers? This time, the two lists are two different ones. Two different lists. How do you make one list of people with their phone numbers? And the answer is group join, because basically group join lets you join two contexts and take the second context as a list that is grouped to the first context and join. Group by doesn't work because it doesn't take second context. You just group by some of your own member. Select would work, but it's not efficient in this case. It's not convenient to do it via select. And select many was the solution to previous problem. It's not a flattening problem. Okay, next. If you need to combine two lists of same type into one, which method will you use? Join, union, intersect, or select many? The answer is union, because the keyword here was of same type. So if you have the same type, you don't need to join, you don't need to merge different type contexts. The problem is different. The problem is stitching two different lists into one because they are of the same type. Merging them, basically. What does iList, array, dictionary have in common? Wow, interesting. Well, the first answer is false because array doesn't store generic items, nor does list, unless it's specified like in dictionary that it does. So it's non-generic. It cannot be indexed in all of them because you don't index a dictionary. You use a key in dictionary. And for the third one, all of those support LINQ because this is basically enumerable of key value pairs. This is enumerable, this is also enumerable. So they all support extension methods. Next. Can an attribute be added on a method? Yes, it can. What must a class for custom attribute have? Like you write your own class for an attribute. What do you need? Right. This answer is correct, and this is not correct because by default it's applicable everywhere, and it definitely does need a custom constructor. What is not reflection? Which of the following is not something that reflection does or has? Okay. The keyword here, maybe someone missed method info, is a type for getting, storing information about a method. And invoking is not the same as calling. You invoke delegates, you call functions. So method info exposes a delegate that can be invoked. Overall, reflection is a difficult topic. It's really not beginner friendly, and I had my struggles as well. And we can have discussions after the lesson and the days that follow. It's not very needed, but it's good to know, to be aware, because sometimes you will need to use it when you're very cornered. Um, Anyways, the answer was this because let's read it again. Calling to string from an object given a type is not known. So everything is an object in C sharp, and you can call to string from anything. Therefore, calling to string from anything is not reflection because everything supports it. It's known, it's polymorphic. So this answer is not a part of reflection. With reflection, we can get method info and call private methods even from the outside. With reflection, we can get property info to see what values do properties have. And we can get property names if we want to see what class, like what did the class have, like Mikhail said in the lesson, during the lesson. Is it faster to use reflection over normal code? The answer is false. With reflection, you need to do multiple steps like getting the type, then calling uh, the property info, method info, members. So there's multiple steps and multiple references involved in order to just do one thing. So it's always slower. And therefore it's not very liked because it's slower. It's stringly typed as well, like there is no strongly typed in reflection. If property name changes, your method will not change its name automatically, so it will fail. Therefore, reflection is not really nice. And when you see code with reflection, or like you have a disclaimer saying this code will involve reflection, you know what's coming and you know that it's not gonna be nice. Should reflection be your last resort? Yes, do not use it if you don't have to. When all other options are denied and have been considered, only then you should let yourself reconsider using reflection. Is it true that attributes by themselves don't do anything? Yes, they need context that triggers and does something with them. They're just flags. What is a flag's attribute? Combined, not combine, is the right, better word. And yeah, that's the answer for this one. Flags, an attribute to allow enums to be comboed. And let's see the winners. Mikhail Fox, number 3. Royalov, number 2. And very close, Aurora, number 1. Congrats. Very even as well. Though I saw different answers, so well done. Homework will be announced tomorrow. No homework today, so that's it for this lesson, pretty much. I also got contacted by one person about potential charity project. We'll see about that. Uh, he didn't reply after I replied to him, so I don't know how serious is that, but we'll see. So one more potential project if the food bank idea doesn't work out. In any case, thank you all for watching and see you next time when we talk about serialization, deserialization. Happy Easter and good night.